children. Today's lesson is your textbook in 6th lesson, magnets. You have learned about magnet in previous classes. We'll see what's in this unit. In activity 6.1, there are some materials. If it is magnetic things or not magnetic things, you want to observe. Magnet hanging by freely. Some materials. What is a coin, an iron nail, a brass nail, a pebble, a plastic ruler. Then here things, only the iron nail attached to the magnet. It is magnetic things. Others are not attached to the magnets. This magnetic things we call materials which attach towards magnets are known as magnetic materials. Materials which are attached toward the magnet, it is magnetic materials. What is magnetic made from? We use iron, nickel and chromium. Iron, nickel and chromium are the metals. This is metal things, magnetic with magnetic properties. Iron, nickel and chromium metals. Some are alloys. What is alloys? Steel and ferrite. Ferrites are alloys materials. The most powerful magnets are made by this alloys, ferrite. Most powerful magnets. You know there are several shapes of magnets. That is bar magnet, plate magnet, ring magnet. This like gulab magnet and U magnet, horseshoe magnet. U magnet and horseshoe magnet. Right? Right. Then magnetic property. Magnetic property or magnetism. Magnetic property or magnetism is a property of a material. Magnetic property or magnetism is a property of materials. Here. Then we want to identify faults of magnet. Faults of magnets. Right? In your textbook, activity 6.2, we want in this magnet, polythene sheet, fillings of iron, and a sheet of paper. Then we covered this magnet by the polythene sheet. We covered this by polythene sheet, and we spread the iron fillings. We spread the iron fillings in the sheet of paper. Then we take the magnet and deep into this iron fillings, and then we take out the magnet. We can observe that in this region covered by iron fillings in mostly attached into these end points, right? Then most powerful magnetic concentrate in these regions. These regions are we call poles of the magnets. More magnetic power is concentrated in these ends. That is the poles of magnets. Then there are two types of magnetic poles. First one is north pole in south pole S. That is the two types of poles in magnets. If we don't know any other poles of magnets, we can use that activity and we can identify the poles of magnet. Then we want to identify poles of magnet. There are no marked any poles. In laboratory, you know, there are some magnets, they have marked north pole and south poles. Some magnets are in not marked any poles. Then we want to identify what is this poles. Right, here magnetic poles. Identifying magnetic poles. Right. There are some types we have identified the magnetic poles. First one, here a magnet without marked any poles, right? Then in first one we use a compass, right? We take fall. The pointer is repulse. Pointer is repulse. It is not in this side is not. This side is not N, not S, right? If it is attached to this, it is S, right? If it is attached, this is S. It is not attached, it is N. Then we can identify the faults of this magnet using a compass. Right. Second one, we hang the magnet freely. Then magnet is stopped in north-south direction of the earth. We can identify using compass what is the N, what is the S, right? That is the second one. Third one, we use a water basin and take a styrofoam or piece of cork sheet that floating on the water. Then keep the magnet on the this plate and it is freely rotate and stop. It is stopped in earth north south direction. Again we use a compass. We can identify what is north, if this is a north or this is a south. Right. Fourth one, we hang the magnet freely and take the closer to marked magnet. Non-magnet take to the closer to the this magnet. If it is attached, this one is S. Like falls. If it is repulsed, it is unlike fall. It is unlike fall. Right. Fifth one, we take two watch glasses and keep in this position. Right. Top of this watch glass keep the magnet. In this watch glass can freely rotate and stop it in earth north south direction. Right. It can freely rotate and it is stop in earth north south direction. Using a compass we can identify if this is north or south. Right. That is the method identifying the magnetic faults. Right. We'll see next part of the lesson next day. Thank you.